Hello, this is Mr. Stansbury. I'm going to take you through the notes on domain and range. At the end of this, you should be able to say, I can determine the domain and range of a relation given a graph or equation. Okay, so first thing, the domain of a relation is what the x values can be. The range of a relation is what the y values can be. Domain and range can be described using set notation, interval notation, or a line graph. Okay, so for example, let's say here's our graph here. So we're basically starting right here. Open circle means it doesn't actually include the point 2, -3, but it starts right at that spot, and then it goes up forever and ever. So the domain is what the x's can be. So x is this our horizontal here. Okay, so what we do is, like right here at 0, x cannot be 0, can't be -1, can't be -2. The smallest that x can possibly be is 2. Okay, so here's where most of us are used to seeing the interval notation. So we say x has got to be greater than 2. Okay, so here's 2, and x is going to be anything that's bigger than that. Okay, now the set notation is, it's the set of all numbers. That's what the brackets mean. Set of all x's such that x is greater than 2. That's set notation. So it's really just a little bit extra from interval notation. And then the number line graph, here's our x, and we say we're starting at 2, and x is getting bigger. Okay, and the meaning of this is obviously the set of all x's such that x is greater than 2. Okay, so for the range, here's our point here. And then now we're talking about the y. So we know that y can be 0, 1, 2, 3. Y gets bigger and bigger. That's fine. It can go down to -3, but it can't go down to -4, -5, or -6 or anything like that. So it starts at -3. That should be -3 right there. Starts at -3. And y only gets bigger and bigger from there. So y is greater than -3. Okay. So set notation is the set of all y's such that y is greater than -3. Okay, or here's our number line, -3. Make sure you state that this is the y and not the x, and it's greater than -3. If this was filled in, then this would be filled in. These would have underlines under them as well, and this means the set of all y's such that y is greater than -3. Okay, so let's try some of these to help cement in that concept here. So for the graph, state the domain and the range. So it starts here and goes up and down and back up forever and ever. Amen. Okay, so domain. Okay, let's just keep it easy right now. We'll just do the interval notation, right? So the domain is what the x's can be. Okay. Okay, so we can see that x starts here. The x value here is -6, -3. So we see that our x starts at -6, and it just gets bigger and bigger and bigger. It doesn't get smaller and smaller. So we know that x has to be greater than, and it's a closed circle, so greater than or equal to -6. Okay, so it goes from here all the way to the right forever and ever. The range is y. So y starts here, goes up, it comes back down, and then it goes back up. This never gets lower than this point here. So basically it's -3, starts at -3, and it goes up forever and ever. So y is going to be greater than or equal to -3. That would be domain and range on that. Okay. Now, there is another way to look at this here, and that is it's really pretty similar, but I do this. I just do start and stop. Okay, so then we do, like, say, domain. And so I'm always going to put the x in the middle here, and then range. I'll put the y in the middle of the start and the stop. So we look and see here, it's like, when does the domain over here, where does it start? And this start and stop is always reading from left to right. So it starts here when x is -6. And when does this thing stop? It doesn't stop, so we just leave that blank. If there is no stop or if there is no start, then we just leave it blank. And then when we do this here, oh, oops, that's -6, not -3. right? And then the x is going to be bigger than that. So this, when we do this start stop thing, this inequality is always going to be the less than. So x is greater than or equal to -6, which is exactly what we have here. X is greater than or equal to -6. You can do the same thing with the y. Where does this thing start? So that would be as we're going left to right and also going, let's see, that really still is just its furthest most like a left point or so. That's still where it's going to start here. So this starts over here at, let's see, -3, and then it goes up forever and ever and ever. Okay, so really this is like the lowest point here, -3, and it doesn't have an end point, so we do the same thing, less than or equal to. So -3 is less than or equal to y, which is the same thing as y is greater than or equal to -3. That's the start-stop idea. Let me try that again with you over here. So domain and range. So we've got start, stop. Domain is the x, range is the y. And sometimes there's more than one of each of these, but for now, let's just try this out. So for the x, as you're reading, going from left to right, where is the beginning of this? And now really, if you look at this as an arrow goes down, it does not have a beginning, and it does not have an end either, because it goes forever and ever to the right. So if it doesn't have a beginning or an end, that means it's all real numbers is the domain. Okay? The range, okay, so the range, the highest that this thing can get here is at 2. Okay? Okay, so really the start and stop on this is going to be, the start is going to be the lowest this will ever be. Okay, and then so we're starting from the negative going to the positive, same like we were starting over here. We're starting at the negative going to the positive, so it doesn't have any beginning, so we leave that blank. And what's the highest point that it'll ever get to? That's going to be at 2. So this will be y is less than or equal to 2. And there's our domain. Domain is domain and range. Domain is the real numbers, range is y is less than or equal to 2. Okay? All right, got one more example, but let's take a quick comedy break first.
A nice catfish.
I love you. I love you. Talk to me. What?
Okay. All right, let's see. Example 5. State domain and range of the functions. Okay, so there's a couple ways to do this. You can just do it just as it looks, figure out what the x's and y's can be. And another way is you can actually just plug this into the graphing calculator and take a look at it just like what we did on the previous one. Okay, I'm going to suggest at least for better understanding on this here, let's graph this. So whenever you want to graph, you want to do y equals. Okay, and there's going to possibly be some other stuff in there. You want to clear those out, and then we're going to enter this in here. So we're going to do 1 divided by, now this is super important. You want to divide by the x and the 2. So what we got to do is we got to put parentheses around that there. Okay, so 1 divided by parentheses, x is this right here. So here's xt theta n, that's our variable. So x plus 2. Close our parentheses, and then usually you don't have to do this the first time. We're going to do zoom standard. Should be pretty good for everything that we need on here. Zoom standard, and then here's our graph. Okay, so if we do our little start stop thing, start and stop. So domain and range. Okay, so here's our graph. So this thing starts, this actually has got two graphs, so we might end up making a couple different starts and stops on here. So the farthest to the left it's going to go is infinity, so it doesn't actually have a start, but it does have an endpoint here. Well, on this one here at -2, so it's really not stopping at -2, but that's where it's going forever and ever, and it's gonna keep going. Okay, so domain is when x is less than -2, right? So here's where x is less than -2. That's all this. And also, it's going to be when it starts here at 2 again, and it goes on forever and ever that way. So we got another start and stop for the domain. So it starts, let's do this, give ourselves a little bit of room here. So we got a second one where this thing started at -2, and then it didn't have an end because it went forever and ever, right? So it starts at -2 here, and it goes forever and ever. So we've got that. So the domain is when x is less than -2 or x is greater than -2. It just can't equal -2, okay? Okay, we could also write that as the real numbers. It's all the real numbers except for -2. You can write it like this, or you can write it like that. Either one would be just fine. This is probably the easier way to do it. And then on this same graph here, the y's, it does not have a beginning. It starts way down there, but then it stops. Like this graph is never going to hit 0, so it doesn't have a beginning, but it does end at y is, and it's always going to be less than 0. And then it's got a second one, right? Here's our other graph. So then now it starts here at 0, and it goes up forever and ever to infinity and beyond, right? So 0, less, so y's got to be greater than 0, and y's got to be less than 0, but it cannot, it's going to be all the real numbers except for 0. So that's probably the easier way to write domain and range. All real numbers not equal to -2. All real numbers not equal to 0. Okay? And we can do the same thing for these here as well. Okay, so we just enter in our square root of x plus 3, and then we've already done the zoom, so we should be able to just hit graph and get a good idea here. Starts here, goes forever and ever to the right there. Okay, so it looks like it's starting at -3, 1, 2, -3 and 0, right? So start and stop for domain and range. You don't have to do the start and stop. I just find it to possibly be a little bit nicer. Okay, so that x, if you'll remember, our graph looks like this, right? And that point there is -3, 0. So this thing starts at -3, and it doesn't ever end. It has no end point. So we just do x is, that's got an actual point right there. X is greater than or equal to -3. So anything that's bigger than -3, that works. And then for the y, the lowest it ever gets is 0. And it doesn't have a highest. Even though it's curving to the right, it's still officially going up ever so slowly. So it doesn't have an end. So then y would be greater than or equal to 0 as well. There's our domain and range. Okay? And then last one, 1 over x minus 4. Okay, so it looks like this, 1 divided by parentheses x square root x minus 4. And we'll graph that there and see what we get. And we get this little weird spot here. So where that's at, 1, 2, 3, 4. And then up 1, 2, 3. Right? Right there. That's interesting. That's a hard one to, it's really a hard one to see. So here's what we can do. We can zoom in on it. So since we really can't tell what's happening right here at 4, just after 4, let's do this. We're going to do a calculation on our graph. So there's the calculate. So we do second trace, which is calculate. Okay, and then we want to know when x equals, well, we know if we put in 4, x equals 4, that's going to give us an error. So with that, we know that can't work. So let's see what happens with 4.1. Oops, not 0.1. Second, calculate value 4.1. There we go. 4.1, we're at 3. Let's try 4.01. That turns into 10. 4.001. That turns into 31. So guess what? 4.0. We put several zeros in there. And this thing's getting bigger and bigger and bigger. So really what this graph is going to look like is this. It's going to go up forever and ever, but it's never going to hit this spot here, which is at 4, right? And it looks like it's getting really, really close to 0, but I'll never actually hit that either. So start, stop, domain, and and range. So the domain, the x, the smallest x can ever be is 4. It can't actually be 4, so x has got to be greater than 4. So as long as x is greater than 4, we're good. It does not have any end, so it doesn't have a stop. And then the y, the range, the lowest this thing ever gets is at 0. And then the highest it ever gets to, it doesn't have a highest ever, so this is going to be y is greater than 0. But it never actually hits 0, so that's why we don't have the equal sign underneath it, okay? Okay, domain and range. That's a little bit of a tricky concept there, but please, if you have any other further questions, please feel free to ask. Thanks.